Backward biasing, it occurs when the positive cell is connected to the N type while the negative pole is connected to the P type. So you reverse it. All right. All right. So when you reverse it, all right, you have um your backward biasing. So at forward biasing, the positive terminal of the cell is connected to the P type while the negative pole is connected to the N type of the diode. While at backward or reverse biasing, all right, the positive pole of the cell is connected to the N type while the negative pole is connected to P type. So at forward biasing, all right, positive terminal is connected to the P type, all right, while the negative free moving electron, all right, is connected to the what N type. But at backward biasing, all right, the positive terminal of the cell is connected to the N type, okay, while the what negative free moving electron is connected to the what to the P type. That's what we have at the what at the both kind of biasing. This forward and this one is for forward, while this one is for what is for reverse biasing. Okay, so take note of that. Quite important. So now let's look at what happened in the both. Well, we look at it diagrammatically. Now in the diagram, all right, of the both values we have when you are talking about biasing. So let's look at the first. Now the first biasing value, okay, from this place. So let's say that your circuit is connected like this. So you have something like this. You have P, your P type. Okay, so you have this, then you have N here, all right, the N type here, or let's put it inside the box, P and N, let's have a source voltage in that place, so this I, positive I, because this is a forward bias. So you have your cell here, all right. So these sticks are both. They are both. This is the P type and this is the N type. So this is like a forward biasing. Then for a backward biasing, what happens is that this one will reduce. Okay, so you have P. So I will show you why it will reduce and become more tiny. This one is very bold, all right. Then this one become very tiny. Then this your N type. Okay, so you have something of this nature too. The power source. Then this your negative value. So you draw it like this. In case you are asked to do it in exam, all right. So this one you have. This one is a forward biasing, which is when the positive terminal of the cell is connected to the P type and the negative electron is connected to the N type, and this is what reverse biasing. So you have negative here, backward or reverse biasing. This when the positive backward, the positive terminal of the cell is connected to the N type, while the negative terminal of the cell is connected to the P type. So what happens? Why is this one all right many or bolder, all right, and this one is very tiny? I'll show you the reason. Okay, now what happened at forward biasing is that there is a drifting when you connect that circuit, all right. There is a drifting of charge, all right, or of charge carriers to the junction, so it will become enlarged, all right. So it will enlarge this junction. So at the forward biasing, there is a drifting of charge. That is a movement of charge, all right, to the center. So the center becomes enlarged, all right. The charge carriers drift to the center and it becomes enlarged. But at the N type, what happens is that it's a reverse. So the charge carriers move away, so it becomes tiny. All right, that's what happens. So at the forward biasing, it causes the drifting of charge carriers to the junction so that it is enlarged. While at the backward biasing, it causes the drifting of charge away from the junction so that it becomes thin. All right. So this one is a good conductor. All right. While this one is a bad conductor. Good conductor, and this is bad conductor, right? So you can note all of these things, very important in electronics. So that is that. Then there is what we call Zener voltage, all right? The other name for Zener voltage is called breakdown voltage. Zener voltage. So when you hear Zener voltage, all right, Zener voltage or breakdown voltage, what does it mean? All right. Meanwhile, I said that your diode as a device is used for rectification of what of circuits. All right, and there's also a device we call transistor. Transistor is used for the amplification. All right, we use transistor to amplify. All right, maybe AC circuit, but we use diode to rectify. Diode is used to rectify. This for rectification. That's the function. Rectification of circuit. Rectification. Then this one is for amplification. Alright, transistor. This diode for rectification and this transistor for amplification. That's a device used in amplification. And your transistor has 3 poles. There are 3 poles of transistor. We have emitter. The first pole is called emitter. Alright, the second pole is called base, and the third pole is called collector. So take note of this: emitter, the base, and the what, and the collector. Okay, so that is that. So now for that, let us move straight away to what Zener voltage is. Zener voltage, I said, is also called a breakdown voltage. You remember that from Ohm's law, we have what V is equal to what IR. I've stated the function of diode and transistor is also for rectification and for amplification. So now let's move straight away. So for transistor, the poles, I've mentioned them, and there are also 2 types of transistor, right? There are 2 types of transistor. These are the poles of transistor which we use for amplification, and there are 2 types of transistor. There's one we call the PNP transistor, and there's what we call the NPN transistor. PNP transistor and NPN transistor. These are the 2 types of transistor we have: PNP, all right, and NPN, all right. PNP, NPN. Then these are the poles of transistor which we use for amplification. Now, a breakdown voltage from this Ohm's law, V is equal to IR. What we have, and what is I is equal to what? V over what? Over R. Zener voltage or breakdown voltage is actually defined, okay, as the voltage at which, right, so take note of that, the voltage at which resistance in the diode is 0, all right, is what we call what? A Zener, all right, or a breakdown voltage. Or we can say where there is 0 resistance for reverse bias and I is infinity. All right, when resistance is equal to 0 and your I is equal to infinity, we can call it what? A Zener effect or a breakdown voltage. It is a point. Zener, you can just say Zener voltage or Zener effect occur. Zener effect occur when your resistance is equal to 0 and current is equal to infinity. It's very simple. Zener effect occurs when your resistance is equal to 0, all right, and what? And current is equal to infinity. That is what we call Zener effect. So what's now going to happen from V is equal to I is equal to V over R. So it happened at the backward bar. So I is infinity. So your current becomes infinity, then your resistance becomes 0. Alright. So if you are writing it, alright, you're going to be having your I now is now I infinity is equal to V of the biasing over 0. This is what happened at what? At Zener effect. So that is that. Alright. So take note of that. Then let us now deal with what we call the poles of transistor. After the poles of transistor, we talk about the difference, how to identify the different types of transistor, the PNP and the NPN transistor. So now for the current that connects, we can use Kirchhoff's law, all right, Kirchhoff's first law to analyze the current of the poles in transistor. Okay, now let's look at it. So for the poles in transistor, there's something I'm going to draw on the pole so that you can identify easily anytime you see. All right, so I'm going to draw this diagram on the board. So we have, for instance, let me show you something from this place. Okay, look at that diagram on the board. So this place, all right, where it rests is what we call the base. All right, base of the pole. Okay, don't forget that we have NPN and PNP. All right, we have NP, and we have NPN. Okay, so now where the electron is entering through is actually what we call the emitter. Then this is the base where it is resting. Then the other end is what we call the collector. Okay, so that is the first. All right, we have. So if it's entering in, all right, we call it what? This, when the position is entering in or going out, is called, then this place is called the base, while this one is called the collector. So this is what happens at what? At a PMP. All right, at PMP is going in, but at NPN it is going out. So to draw NPN now, what is going to happen? For NPN, you are going to be having the same diagram. All right, so you have a base. So the base now, it should now be going out. Sorry, the emitter rather will now be going out. This is your base, of course. You have one other line that substances. Here is called the collector. Then as it's going out, now it is now what? And so if it's coming inside, it is PNP transistor. But if this direction is facing outside, it is what? NPN what? NPN transistor. Alright? This coming in, then the arrow is facing back. That is the difference when you see, or if you have to draw it. So this place becomes the emitter, where it's going out. Coming in and going out is the emitter. This is the base, and the other one is called the collector. And using Kirchhoff's first law, the current analysis between the current of the emitter, current of the base, and current of the collector is combined together by saying, using Kirchhoff's law, current of the emitter is equal to current of the what? Of the base plus current of the what? Collector. Current of the emitter is equal to current of the what? Of the base plus current of the what? Of the collector. This is what we have for the three currents that exist in the phone. So if it's coming in, it is PNP transistor, which is our amplifier. Then if it's going out, it is what? NPN, which is what? The diagram we have in that place. Okay, so that is what we should take note of. All right, quite important. All right, so all of those things on the board are actually what we can basically see about resistor or semiconductor at large. All right, so if that video helps you, all right, watch it very well, and far beyond, put them into practice. If there's any question you have, I've always said, subscribe to my YouTube channel, and if there's any question you have, send it to this number 48 and what? And 47. All right, 090745648 and 47. So we see again. God bless you. So do well to revise those things, make your research, and send me questions. Thanks for watching.